A couple things you're going to notice is that there is a connection between G and E. So the acceleration due to gravity and this electric field. Okay, so look at the formulas. Look how similar they are. Little g equals big G m r squared. Big E equals kq r squared. So notice they have a similar form. The constants, the values themselves. G is the measurement of the gravitational field strength, where E is the measurement of the electric field strength. Big G is the gravitational constant. Little k is Coulomb's constant. M is our mass of the body producing the field. Q is the charge of the source charge producing the electric field. And then R is the distance from the center of the body. R is the distance of the center of the body. So very similar. Our next example, a tiny metal bar, which has a charge of -3 times 10 to the -6 coulombs. Determine the magnitude and direction of the electric field it produced at a point P 30 centimeters away. Okay, so E equals kqr squared. We're going to put Coulomb's constant in. We're going to have our charge right here, and we're going to have our distance. When we calculate that out, let's look at the units. Newton meter per squared per Coulomb squared times by coulombs divided by meter squared. So our meter squared cancel out. Coulombs over Coulomb squared, we're left with a coulomb. Newton per coulomb. Okay, this becomes 3 times 10 to the 5 newtons per coulomb. Now the direction came from the charge. If we have a negative source charge, remember our test charge is always positive, a negative and a positive means it's going to go towards that source, towards that metal ball. Remember, the electric field is always defined as being in the direction that a positive test charge would move. So that's what I tried to explain. Since the source charge is negative, a positive charge would be attracted. This field points towards the metal ball.